Hey everybody, Lars here. Time for review video number 2 for the infamous unit number 3. Um, if you have noticed that I'm wearing the exact same outfit that I was wearing when I shot the homework review video, you are not going crazy. I'm not like Ted Kaczynski, although I may look like Ted Kaczynski sitting in my dilapidated little trailer here in Metuchen, New Jersey. It's not a trailer. It's a dilapidated old house, but it is dilapidated nonetheless. Um, I'm shooting this on the same day that I shot that homework review video last Saturday, the 8th of October. If you recall, I was 2 hours before the Rutgers game, and I was going to shoot that homework video, and then I was going to cook up some dinner, some chili and some stuff, and I was going to sit down and watch Rutgers versus Michigan. Oh, you always have a chance at the beginning of the game, and oh, it's raining outside. Maybe we, can do something on the ground. Boom, boom, boom. Wrong. The final score was Michigan 78, Rutgers 0. I believe I read it was the greatest beating we took in like the last 130 years. I think Princeton won a game like 80 to nothing, or no, 80 to nothing happened in the 2000s or something. Anyway, it's one of the most lopsided victories in college football history. We got destroyed, completely destroyed. I forget some of the stats. I know at halftime we only had 1 yard of offense to Michigan's 311 yards of offense, and they were up something like 42-0 at the time. It was a beating, an old school beating. So I decided I was going to rally and I was going to put together the second review video because, like I always say, I want to get you these things early, so I want to make sure I have this thing in the can and it's ready to rock and roll for you. So today we're going to go over some stuff with file I/O, and when I say I/O, I mean input and then output. And when I usually start this video, I usually tell the story, and you've heard it before because I know I've mentioned it before, about when I was a student at university, St. John's University in Queens is where I went to and did my undergrad work. And they didn't really have a handle on how to teach computer science yet in the 80s. It wasn't just St. John's. Nobody did. And what they did was they gave you an introduction course, kind of like we did now. So they would give you a first language. In my case, I think it was Pascal. And teach you some computer concepts along the way. You got searching, you got sorting, you got recursion, you got all those fun things. And then the second course, as it is now, was data structures. So they would teach you about things that you're going to see in Unit 6, stacks and queues and binary trees and things along those lines. But then after that, it was completely the Wild West. They just threw everything in the kitchen sink at you. They hadn't really wrapped their heads around how to teach discrete mathematics properly, so they would just shoot people over to the math department and say, take a couple of probability and statistics classes. And there you could cover most of the things you have to go through with discrete mathematics. Not all, though. They had to incorporate some of the things with set theory and graph theory and all that in the computer science courses. They had some other courses that you still have nowadays, operating systems, compilers, which you had to take back in the day, security, things along those lines. But what they really did back in the 80s was they threw a bazillion different language classes at you. So when I was a student, I took COBOL, I took Fortran, I took PL1, which was C before there was C. It was used to write big operating systems for mainframes. Famous one called Multics. It's actually Unix's great-grandfather, was written in PL1. I was lucky enough that I came along at a time where they were beginning to teach C, so I took C. And you ended up learning all these different languages, and what happened after you took all of these language classes is you would abstract out the important things. You would say to yourself, okay, I'm getting another language. How do I do simple data? How do I do arrays or lists and sequences? How do I do functions? Only then we didn't just call them functions, they were called procedures, and you would pass by parameter or pass by value. And then also we would call them subroutines in some cases. And then later we would deal with functions, and functions that had return values exclusively. If you did something without a return value, you called it a procedure and things like that. So after taking all these language classes, you knew all of these big basic topics, and basically what you had to do was when you started a class, you're like, okay, let me wrap my head around how to do all these things. But the one thing that always got passed over was file input and output. And I always thought that was crazy because that was something important to know. When you get your first programming job, you are not going to be told to create a list of the first 200 Fibonacci numbers. You're not going to be told to take a list of the first 500 natural numbers and square them. It doesn't work that way. You don't deal with data inside of your programs like you do when you're learning. You will almost always be given a file. And that file will contain numbers to work on, or that file will contain text and numbers that you have to separate and clean up. Or you will get an Excel spreadsheet that you could take and use as data and pick apart. You can actually do that with Python. Later on down the road, there's a library that allows you to read Excel spreadsheets, and then you can access all the different data by where they are, where their cells are, and things like that. So I always thought file I/O was pretty important, and they never went over it. So, as I always say every time I shoot this video, this little section of the course is my message back to the people that taught me computer science back in the 80s. I always told myself, if I ever became a computer science educator, I was going to do file I/O. And true to that, I do it every time I teach programming because it's important, not just because it's not just good foundational way to learn how to program properly. It's useful. It's utilitarian. You're always going to deal with files, and it's a good idea to see these things in the context of your first programming class. What is a file? If you think about the way we've been dealing with data so far, we've just been creating lists and files, create the first 500 numbers, use this, use that. Here's a list with names and numbers in it, things like that. That's in the real world, it doesn't work that way. You're probably already aware of this, obviously. Somebody is going to give you a file full of data, and what a file really just is a durable store. It's a durable place where you can keep your data. It's a place like the reason we do programs. I can type a whole bunch of commands into the Python Interactive window. That's great. When I turn my computer off and I come back the next day, those commands aren't there anymore. Excuse me. That's the reason we save all our commands in a program. So on the data side of things, think of a file as just the place where you save your data so that at the end of the day, I can turn my computer off and I can come back tomorrow morning and I can turn it on and my data will still be there because it was kept in a durable store, in our case, in a named spot on our hard drives that we have come to call files in the way we do operating systems these days. So that's really all it is a durable store of data. So we're going to go over the simplest ways that we as Python programmers can deal with files or data that's been stored on hard drives. Because I'm a good doobie, already have some code written up for us, and we will go through it and we will explain it. Now, I have on my hard drive, on this particular machine, a file called small e22. If you have read the slides already, you know that there's a big file called e22. I think it is e22 because it is the data feed for the 20-second Euler problem at Project Euler. But I created a smaller one so it's easier for us to work with. And if I double click it, it'll pop up with Notepad. You can see it's just a file that contains a whole bunch of names, and those names are in quotes, double quotes, and they're separated by commas. So we would commonly call this a comma-separated value file. Okay, so that exists on my hard drive, and it happens to exist in the same folder that I have this code in, file stuff. That is important, and we will see why in a second. So let's quickly just go over the simplest thing we can do with a file with Python. We're just going to open the file. We're going to read in all of the information in the file, and then we're going to close the file. And that's how we always start out, with those three basic operations. We open, then we read, and then we close. And the way we do that is, first thing, the way I do it, is I set up a string variable called infile, and I make it equal to the name of the file. Because this code resides in the same directory as the file, I can just give the file name. But if I knew exactly where on the hard drive was, I could give, what's called the absolute path. I could go C colon whatever and give you the path right to that object. This is what would be called a relative path, or hey, look in this directory and you can find it. So right here, I'm just creating a string though. I'm just creating a string that happens to be the name of my file. So the second thing I do is the important thing. I grab a variable called f, and I assign it the results of this operation. I use the built-in function open, which is made to deal with files. You saw built-in functions when we did the first section of this particular unit. And I give it the string, which is just a name. I didn't have to do it this way. I could just have hard-coded that name in there if I wanted to. And then I say comma, and I say R, just a single character R. What that tells Python is, open this file for reading. The R is for reading. You're going to see later in this video that we could also put a W there. And we could open this file to write to. And we're going to write our own output files in a little bit. But for right now, we're opening this file just to read. Okay? Now, the second line here, I create a variable called data. And data is going to hold a string because this operation here creates a string. And all it does is I say f dot. That means I'm going to run a method on it. Remember, methods are those little functions that we can run on certain kinds of things. This is a method that we run on a file. And this is a file because we set it equal to the open file function. And I'm just going to say read. No arguments. That is a function without arguments. We learned about them in the last video. So all of the data from that particular file is going to be stuck in that string. Okay? It's going to be a long string. We'll be able to see because we'll be able to look at the length of it. Okay? Then, because we are good citizens, I always call it being a good file IO citizen, we are going to close our file. When you have an open file, you have a bunch of data that's being kept in memory, where that file is, what my place is in that file, and things along those lines. It takes up memory. Back in the olden days, memory was scarce, so you always made sure to close your file so that memory could then be returned to the heap for use later in that same program. Now, we're lousy with memory, so people don't close files as much as they should, but that is the wrong way to do things, and we are not going to do things the wrong way. We are going to do them the right way. So the very last thing I do here, I've already got my data. I've got it in that string. So I'm just going to run f.close, and I'm going to close my input file, and then we've got what we wanted. We opened the file. We grabbed all the data out of it. It now resides in a string called data, and then we closed our file. So then just right down here, I'm just going to print data, and I'm going to print that string, and we are going to see what it looks like. And there, you can see it's printing all of those names, and there's a bunch of them. Now, I have a string with all of this information in it. So if I do a length of my data, what is it gonna... Uh-oh, that's not where I want it to be. I want to be there. So if I do a len of the data, what's it going to tell me? It is going to tell me... it's going to tell me that I haven't set up my windows properly. There we go. It's going to tell me 5,128. Now, remember, I'm running length on a string. So that's the amount of characters in there. Okay? It's not telling me the amount of names. It's telling me the amount of characters that particular string has. So we got the data out. We have a string, but it's not particularly useful right now. I mean, sure, I could slice into it, and I could do a bunch of other things, count how many characters it has. I could write some kind of convoluted loop that goes through and looks for the quotes and then gives me everything until it finds another quote, something like that. But I don't have to make myself crazy like that, because now I'm going to take this string, I'm going to clean it up, and I'm going to turn it into a list. And the way we do that is when we clean our data. And of course, I've got cleaning data code ready to rock and roll for us. Let me do that because I've got other code down below there. So now I save this. So when we clean our data, we're going to do two things to it. The first thing we're going to do is we're going to take our string data and we're going to run a method on it called replace. And what I'm going to do is I'm going to replace all of the double quotes with nothing. And you could see nothing, or I mean, if you watch the homework review when I did the Double quote gives you the empty string. It just gives you the empty string. That's nothing. That's single quote, right in a row. Boom, boom. Okay? So basically, I'm going to get rid of all of the double quotes in that file. And actually, you know what? Let's ditch this part and take a look at it so we can see what that looks like. Okay? So now when I rerun, you know what? Don't print that. And that should be good. Let's see what we get. All right, now you can see we've printed our string because it's still a string, but now it just has comma-separated names. We have removed all of the double quotes and we just have names, but we still just have a string. Okay, we can confirm that idea by taking a look at the type, and you can see we're still a class string, but we're going to change that. We're going to change it right now by doing this. We're going to use the split method. When you run the split method on a string, it does two things. One, it takes this item that you give it right here, what's called the delimiter, and it's going to split every time it finds one of those things, a comma, and usually we use commas. Although you're going to see in another context, I think in the next video when we go over some homework stuff for your assignment, I'm going to use something else for the split, but that's for another time. Right now, we're going to split by these commas. And every time there's a comma, I'm going to grab a new item. The thing is, if I want to keep a group of items, what do I want to do? I want to have a list. And this particular method doesn't return a string. It returns a list. So what's going to happen is I'm going to take this string data and I'm going to split it. And everywhere there's a comma, I'm going to create a new item. And now data is going to be a list. And I'm going to be able to print it that way. As a matter of fact, well, let me do this first. And you will see. Watch. So now I'm class list. So now I have a list. So you'll see when I print data this time, save and run, everything is in a list. See? And that's a good amount. You can see right there the starting bracket and all of my strings. It's a list of strings are in single quotes. So I can see I now have all those names separated out. So now I have a list called data with all of the different names. Now, if I do a len on it, it's not going to tell me the amount of characters. It's going to tell me the amount of items. So I know now I have 579 names in this particular list. So what you might be saying is, yeah, great, big deal. You took a string, you made it a list, blah, blah, blah. No. List is what I want. A list I can operate with, because a list is a data structure I can navigate over. I can navigate it over it with iteration. Item by item, I can now look at my names. So I whipped up another piece of code right here. Exhaust this other stuff out. So now I can use this. I can set up a counter C. I can iterate over the list. I can say for I in data. Okay. You saw this if you looked at the review video I did for FizzBuzz and the rainfall problem, but if just in case you haven't, this little thing is equivalent to C equals C plus 1. Okay. This operator right here says take that variable, add that to it, but keep the amount that was in there before. It's not an assignment. It's basically the way we keep a counter. Okay. So I click a counter, and then I say if I, and I'm looking at each name individually as I go through this list, if it equals Elva, and Elva's around here somewhere, Elva's near the end, then print it. Print where it is and print Elva. And then it still, nothing stops it. It still runs through to the end. So at the end I print C, and it'll tell me exactly how many items are there. So now if I run this piece of code, boom, it tells me I have 579 items because I didn't zotz out that other part. Elva is the 553rd item, and I have 579 names in the list. So Elva, where is Elva? Dun, 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 dun. I have done this video before and been unable to find Elva, and Elva was sitting here right on the screen, as I'm sure it is now, and I just can't find it. There's Elvira. Let's see, 553, 579, somewhere around here, yeah. All right, I'm not going to waste our time looking for that. There's Elsa, there's Izzy. I can find everything except stupid Elva every time I do this. All right, once again, a failure. So now I've read the data in from a file. I've taken that string, that long sequential string of data, and I've cleaned it up. So I've gotten rid of the quotes, and I've now put everything in a list. And as you probably know, a lot of data is given in comma-separated value format. This is how you deal with it. Okay, just those two lines. Boom, boom, boom. Now everything is sitting in a list for you to iterate over, for you to use. If these were numbers, we could add them or perform calculations with them. We can do basically whatever we want. Okay, so this is the very basics of file I/O when it comes to using Python. There's a couple more things I want to show you. Actually, there's 1, 2, 3. There's 3 different things you and I are going to review. And the next one is real quick, just another way that we can deal with opening files. You can see down here I have what's called a with construct. And again, you don't have to know anything about it. You're not going to see this on a quiz. You don't have to use it in programs. It's one of those things, like I always say, I want you to know about it. I want you to be exposed to it, because one of the big things, me as an education person, I deal with communities of practice, and you are now trying to make your way towards the center of the community of practice that are Python programmers. So Python programmers know about this. Python programmers probably use it exclusively whenever they get a file and they just want to read things line by line. The with construct just says, hey, with, and then you put in your open command right here. You open for reading. It's like, with this file as f, colon, do this. And then you go jump right into a for loop and say for line. It doesn't have to be I. It doesn't have to be J or K. You could just call it, in this context, line. Just say for line and f, print the integer of the line. Okay? Now, I look at a file here called numbers.dat. Call me crazy, but yeah, I have numbers.dat is just 12, then 23, then 34, on down the line. Okay? But this is a sequential file, so whenever you have a sequential file, you really have 1, 2, new line, 2, 3, new line. So that \n is in there. You just can't see it because it's a special character. So I am opening that, and when I open it, for every line, I'm going to cast it into an integer, and I'm going to print it. So when I run this, all right, I have too many thingamajobbers, I bet. Is that the case? No. That should work for... that should work. Why isn't that working? End of line while scanning. String literal. And you're dumping me... Oh, it's just... that you don't need to be seeing. That you don't need to be seeing. So that's a string. Oh, 4. Goodness gracious. What a doofus. All right. Now I think we're going to work. All right. So as we just saw, when we took a look at it, there's numbers right there. 12, 23, 34, down to 67. And what we have right here is 12, 23, 34, down to 67. Okay? So with that simple 3 lines right there, we opened it, and then line by line went through it, and in this case, I just printed it. Now, one neat thing about this, and you might be screaming, but wait a minute, hold on, you didn't close it. With closes the file automatically. When that construct is done, when that loop is done in there, that with block completes, the file is automatically closed. So you don't have to worry about closing that file, okay? The read is implicit. So as I run through this, I've opened it up for reading. So these operations are read operations. So when I grab line, I'm reading from the file. That happens automatically. So with is a nice little construct. Again, I just want you to know about it. I just want you to see it. Don't start writing all your code with it and then send me a million different emails. My with doesn't blah, 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 blah. Don't worry about with. Please, feel free to use these up here. Feel free to use open. Use open and close. It's probably better that you do it that way. But I want you to know that with exists. Because as far as reading things line by line down a sequential file, it comes in handy and it's very useful. And a lot of Python programmers use it. So I want you to be aware of it. Okay? End of with. Later, at the end of this video, we're going to talk about pickling. And it's the same situation with pickling. Do not get crazy about pickling. You will not get quizzed about pickling. You will not get pickling in an assignment. You do not have to know anything about pickling. I want you to see it. I want you to be exposed to it, because when Python programmers talk about things, I want you to be aware of these things. It's like, I never had that in that stupid class I took at Rutgers. I don't want you to be that way. I want you to have been exposed to these things, that have seen these things. All right, we got one last thing to do, and it's pretty important. We are going to deal with output files, okay? Files aren't just for reading. They're also for writing. Because when we read in our data, oftentimes we want to do something with it, and then we want to take those results and write them out. I mean, in our particular context, we're doing this in a programming class. We just print things to the screen, and we print answers to the screen, and whoever runs the program can see the answer, and yay, we won the day. But in real world, we want to input things from a file, do processing, and then take those results and write them out to another file. And then those results are there to either send somebody, or oftentimes they can be used as input to another process that we use with programming. So output files are just as important as input files. So what we're going to do is right here, I'm going to create a variable called OF for output file, I think. And then we're going to open it, and outnums.dat is just created out of thin air. Look, there's no outnums.dat there, okay? We're going to create it. So create the name that you want for your file, comma, and then boom. Instead of an R, I give it a W for writing, okay? Then I jump into my numbers file again. Yes, I'm using with again. I should rewrite this and use the old-fashioned way, but I always use with. You'll see when you're a more experienced Python programmer, you're going to use it a lot, because a lot of data is given to you to be read line by line, and if it's to be read line by line, this is like a piece of cake. So yeah, we just do it. So I open the numbers just like I did before as F, and for line in F, this time I'm going to print the line. Only I want to cast it, because if I'm reading from a file, I'm reading it as a string. So I'm really getting 1, then 2, then new character, \n, or new line. Okay, I want to cast that so I get the number 12. Okay, then I'll print it. Then I'm going to create a variable called bump. And what bump is going to be equal to is I'm going to take that number, I'm casting it here too, because I'm not, I didn't save it anywhere. I just printed it out as an integer. And I'm going to add 1 to it. And then after I add 1 to it, I'm going to write bump to the output file. So you can see here, I take bump, I cast line to an integer, and I add 1 to it. So the first thing I read in will be a 12. I'll add 1 to it. Bump will be equal to 13. Then I want to write bump. But here's the catch. I got to go back to strings again, because I'm writing to a sequential file. Sequential files, reading, writing, simple file I/O is with characters. So I want to turn it back into a string. And when I turn it back into a string, I want to make sure I add that \n so that it prints properly. So I just do that with a simple concatenation right in the middle of the write function, or method in this case. So I have my output file. I'm going to write, instead of read, I write to that output file. And what am I going to write? I'm going to write the string bump, which in this case is 1, 3, and then I'm going to add a new line. And I'm going to do this for every line. So as I go through, 12 becomes 13, 23, 24, 34, 35, and on down the line, okay? I have commented out that last line, and you are going to see why in a second. So I think I've got some decent code here that's going to work. Let's go and run it. And it reads my file, and look at that. It prints out all the numbers. That's great. So now I should have an output file called outnums.dat. Let's go take a looky-loo. Outnums.dat wasn't there before. Remember? There's nothing in my hands and there's nothing up my sleeves. I showed you the directory before. We just created that out of thin cloth, but there's a problem. And the problem is over here. Dum, 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 dum. If I double click on outnums, there's nothing there. There's nothing there in that file. It's been created, but there's nothing there. And there's a reason there's nothing there. I'm going to delete it so we can run it again. Hold on. Oh, of course I can't, because it is being used. It's being used because it was never closed. Look at this. you have to make sure you close output files. Because if you don't close output files, you won't write any of your results. A little bit of behind the scenes when you do computer programs like this. Any language being implemented on a laptop or something like this. When you're creating output files, you're not writing to the file every single time. You're writing to a little area of memory, okay? A little piece of memory grabbed from the heap, and you're writing all of your things to that thing. When you close, you take that little piece of memory and you write it to the hard drive. That's when it happens. So with input files, yeah, I can read my data. If I don't close, it doesn't really hurt me in any way, except that it uses memory, and I don't care about that because I have a lot of it. With output files, it hurts you because it never gets written to the hard drive. So then you can, you never save it. You never really do it. You have to remember to close output files. Now, when we rerun this, looks the same on this side of the fence because all I did was print out the original number. But now when I return triumphantly, I see outnums and I see that I have something there. And as you can see, let me get rid of all this. Outnums is indeed one higher up and down the line from the original program or the original number file. So I've successfully taken that file numbers.dat, grabbed each line, added one to it, and written a new file called outnums, outnums.dat. Okay? And because I closed, it took all my data that was in a memory space, bloop, and it wrote it to the hard drive. And now I've got an honest-to-good, look at that, Pinocchio's a real boy. I've got an honest-to-goodness file sitting in my directory that is the results of the processing that I did in my Python program. And that's the name of the game. You want to take an input file, do some processing. After you've done that processing, write it out to another file. And then you have, then tomorrow, if I want, I can come downstairs and I could use this as the input. Run it again so I could get 14 and 25 and 36. And good God, how boring. Okay, but if you wanted to, you could do it. Because that's the name of the game. You want to be able to read in your data from a file, do the processing you want to do. You can still print things to the screen and do things along the way, but then when you come up with your results, you want to write it out to an output file. And then you have it to send to your boss or to send to somebody else or to post online or to have so you can use it as an input file the next day. All right? All right, there is one last thing we want to do. As always, there's nothing down there. Grand finale? Yay, nothing breaks. Kind of boring, but grand finale nonetheless. I'm going to take file stuff, and I'm going to put it in your Sakai resources under Unit 3. So you're going to have it if you want to look at some file I/O stuff, play around with the width, play around with output files, get things working on your own system so that you can read files from your own system and then write them out too, okay? Remember, just keep this in mind. This is very simple file processing. This is file processing with what we call sequential files, okay? We're not reading in binary objects. We're not reading in a bunch of other things. We can with Python, but right now we're starting out with the beginning stuff, and we're reading sequential files, which start at the beginning of a file, go character by character. You can use offsets too, and read things in as character strings, okay? In the future, you're going to be able to do things with binary, do things with objects, read other things. But right now, we're just starting off with sequential files and doing things that way, all right? All right, good, good, good. Look for filestuff.py up in your resources. There is one more thing we have to tackle, and you can put down your pencils, and you can relax, because we're just going to talk about it. We're not going to create any code. And what we are going to talk about, dun, 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 is pickling. Pickling is one of those topics, again, like I discussed with the with construct. You don't have to memorize anything. You do not have to answer a pickling question on a quiz. You do not have to do any pickling in any Python program that you write for this course. That should tell you that after you read about this and know about it and store it in a little place in your brain, that's all you have to worry about pickling. Do not start playing around with pickling code and send me 5 different emails about my pickling code doesn't work. I'm trying to save it. Stop. It's not important. It's one of those things that I want you to be aware of in case you hear people talking about it. Okay? Pickling is the way that Python does a process called serialization. Okay? Back in the 80s, when object orientation started to become popular and C++ in the late 80s came around, a lot of people were doing object-oriented programming, myself included. And what people started to realize was that if you used simple file processing, it was easy to save a string to a file. It was easy to save an integer or even a floating point number to a file. But objects, at the end of the day, they're really custom-made data types, were not so simple to just write to a file because they were complex constructs. Sometimes you had pieces of data that were a string and then a number, and that was a particular piece, and then under that you'd have a number and then something else. Then you would have the code that went along with that data, and you'll understand more about what I'm talking about when we do classes. So these were complex data types, and it wasn't so easy to just write them to a sequential file, because think about the term serialization. What is serial? We're not talking about cereal like Captain Crunch or, Fruit Loops. We're talking about serial as in straight line, as in serial circuit versus parallel circuit, okay? A sequential file is serial. It is boom, 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 a straight line of data going across. When we save our simple data types, it's easy. The string, 1, 2, 3, put your name there, 1, 2, 3, 4, 5. Then an integer, 1. Then a floating point, 1, 2, 3, dot, 1, 1, 1. It's easy to do sequentially. With a complex data type, like an object, actually an instance of an object, well, an object, sometimes you had to extract all of the data and all the information out of it and then put it in a form that could be written in a straight line. When you did this, the process of taking a complex object and creating it so that all of its data was in a straight line so that you could write it to a simple file, that process was called serialization. Okay? Lots of times in the very beginning, you would write your own code to do serialization, but later, C++ and some other, and Java, obviously, Java was sophisticated enough by the time we got to Java that there was already code written for you, and there were serialization libraries so that you could, write your objects to files and then go read them back in again. Oddly, back in the 70s and the 80s, this process was called marshalling. It was called marshalling your data. And it was basically, it's what it sounded like. It was controlling your data, putting it in another form so that you could save it simply and then bring it back and then build it back into something complex. For whatever reason, that term sort of went away in the mid-late 80s, and we started using the term serialization. I am not positive. I'm not a historian on these points, but I do believe it was around when C++ reared its ugly head. It was when everybody started talking about serialization in those terms. So people would then say, oh, you have to serialize the object before you can save it to a file, then you read it back in, and then you unpack it and create your object again, boom, boom, boom. For whatever reason, and I don't know why, when data warehousing became popular in the 90s, they started using the term marshalling again. So it's almost like the terms are interchangeable. They're really not, because marshalling speaks more to saving an object with the data and the methods and the functions you could do with it, and serialization is usually just the data, but they're very similar, so a lot of times people will use the terms interchangeably. Marshalling or serialization, when you hear that, all we're talking about is taking a complex data type or object and making the data in it simple so it can be saved in a simple sequential line, and then that can be saved to a sequential file like we've been doing for the last 15, 20 minutes. In Python, to finally get to the point, we call the process of serialization pickling. And there's actually a library that we use called the pickle library that has a whole bunch of commands and a whole bunch of different methods that we can use in order to pickle our objects. You can see the code that I do on the next thing. We just create a simple list and we pickle the list. Because as you're going to learn in Unit 6, a list is just a data structure at the end of the day. And it's also an object. So we can pickle lists. So that's basically whenever you hear pickling or I need to pickle something or someone's going to pickle something, it's Python's way of doing serialization. It's Python's way of taking a complex data structure or object like a list, or later you're going to see an object that was created with a class, and putting the data in a straight line so you can save it to a simple file. And then when you read it back in from that simple file, you can reconstruct that complex object and have it the way it was before you had to save it and put it away, okay? That's it. That's all you have to remember. You now know about pickling. Not going to be on a quiz, not going to be in a programming assignment. You never have to, if you choose, you never have to let pickling darken your door ever again. But you will, because you're going to end up a Python programmer later down the line, and you're going to have a bunch of objects, and you're going to want to save them. And you're going to say, oh, yeah, I took that class at Rutgers, and I know what pickling is all about. You're going to Google Python pickling, and you're going to be in Fat City. All right? All right. Then that's the last thing we're going to say about pickling. And that is it. Okay? This is the second of 3 review videos for Unit 3. Very soon, I don't know what night you're going to be getting this. I may unleash this on you Tuesday night, maybe Wednesday night. It's around this time that I'm going to release the homework assignments. I'm not going to say anything about the homework assignment tonight because I'm not really sure when you're going to get it or how you're going to get it. But one thing I will tell you is that when you first get it, don't go crazy. Because in the next video, I think it's the next video, or maybe I do a 4th one, we're going to do a sample program. And when we do that sample program, there's going to be a lot of aha, eureka moments for you if you know about the homework. You're going to say, oh, okay, I can do that. Oh, okay, I can do that. So don't let it make you crazy. Engage with the resources. Read the slides. Read your Zell. Watch these videos, okay? Unit 1 video on functions. Unit 2 video now on file I/O. 3rd one, we're going to talk about libraries and different things along those lines, okay? So we're moving along. Unit 3 is moving along. Everything's going to be fine. Everything's fine unless you are a member of the Rutgers football team. Then things are most definitely not fine. 78-0 is an ass whooping. An old-fashioned country ass whooping. So we'll see if we can get through that. And actually, you know what? You got to give him time. You got to give Chris Ash time to recruit his kind of kids and his kind of players and do some recruiting. So we're not going to know what kind of program Rutgers is going to be for 2 or 3 years. I have no reason for this, but I happen to be optimistic. I happen to think that Rutgers belongs in the Big Ten. Once Rutgers recruits, they now have who is undoubtedly a Big Ten head coach. They're going to be able to recruit players. They're going to get bigger. We're already better on the line. People can't see it because the teams we're playing are world beaters. Washington's number 5. We played them in week 1. We played Ohio State. We played Michigan. I mean, these are the top 10 teams in the country, in the universe, okay? So it's real easy for your usual jerk at NJ.com to say, oh, Rutgers is terrible. Rutgers, blah, 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 blah. Garbage. They've got decent lines now. They're starting to form offensive and defensive lines that can compete in the Big Ten. We got to get better at skill positions. We've got to get better in the secondary. We have to get some linebackers that can run 5 steps in a straight line without falling over. But that's going to happen. He's going to recruit kids, and things are going to get better. All right? Now, how this turned into an opinion piece on Rutgers football, I don't know. It is a programming video. So keep coding. Keep engaging with the resources. Everything is going to be good. I'm going to get out of here. You will get video 3 very soon in the next couple of nights, I'm hoping. And you will get the programming assignments, and you will see it's going to be fun. It's going to be interesting, and you are going to learn Python. All right? Good. Then you have a good night, and I'll talk to you later. Bye.